Welcome. Thank you for joining me. My name is Brian Murphy, and I am the head of hydrogen and low carbon gas research here at S&P Global Commodity Insights. I'm going to talk today about a new trend that we're seeing in clean energy markets, specifically ammonia emerging as a new low carbon product across a variety of end use sectors. Ammonia is a hydrogen derivative. Its chemical formula is NH3. It contains 3 hydrogen atoms. So this growth in demand for clean ammonia that we're seeing from these end-use sectors is a catalyst for growth in clean hydrogen markets and clean hydrogen production globally. To capture this trend, I want to talk about 3 topics. First, we'll discuss existing ammonia markets and production technologies to set the stage. Second, we'll talk about how ammonia production technologies are evolving to make ammonia with a lower carbon footprint. And third, we'll talk about how new demand for this low carbon ammonia is impacting clean hydrogen development globally and what hurdles to widespread adoption remain. So to start, existing ammonia markets. Ammonia is a major global commodity. It's used primarily in chemical fertilizers, also used in specialty chemicals. It's estimated that the food supply for half of the world's population is supported by these chemical fertilizers. So it's obviously a necessary product. Globally, we make about 200 million metric tons of ammonia each year, and it's produced by reacting the nitrogen in air with hydrogen in what's called the Haber-Bosch process. That hydrogen specifically comes with a significant carbon footprint. So anywhere between 10 and 20 tons of CO2 for every ton of hydrogen, because it's synthesized from, most often, natural gas or coal. As a result, ammonia synthesis accounts for more than 1% of global carbon emissions. Turning to the technology story, the emissions of ammonia synthesis can be mitigated through 2 major technologies. The first is adding carbon capture and sequestration to a traditional production facility, either via a retrofit or a ground-up redesign, or switching to renewables-powered water electrolysis to produce the hydrogen. Water electrolysis is a technology where electricity is passed through water to split the H2O water into hydrogen and oxygen. These 2 technologies can reduce emissions by, on the low end, 50%, but we can go all the way up to more than 99% emissions reductions depending on the chosen technology and the specific design of the system. However, this does come with added cost, and low carbon ammonia is more expensive than traditional ammonia today. The cost premium is anywhere from 30% in the very best cases, all the way up to double or even triple the production cost when you get into the higher cost cases that we look at in our analytics. And these high costs for low carbon ammonia are the main barrier to uptake of this new product in both existing and new markets today. So speaking of those new markets, we are seeing low carbon ammonia gain interest in 2 key end use markets. The first is power generation, and the second is the maritime sector, where ammonia can be used as a liquid fuel that can be combusted with no direct carbon emissions. This is similar to hydrogen. Hydrogen can also be burned without associated carbon emissions, but ammonia is cheaper and easier to both store and transport than hydrogen is. Thus, when we think about resource or space-constrained applications, like power generation in countries like Japan or South Korea, or global bunker fuel, global shipping, ammonia becomes an attractive decarbonization option. We've seen key policies that have been put in place already to incentivize uptake and use of low carbon ammonia as an energy carrier. And we've also seen, in response to those policies, required technologies advance quite rapidly in recent years. Specifically, and most importantly, we've seen Japan and South Korea implement contract for difference subsidy schemes that support the use of ammonia, often ammonia that might be imported from overseas, in their domestic power generation sector. Initially, this ammonia is going to be blended with coal in existing power stations with the goal of moving those power stations to 100% ammonia in the long term. Turning to shipping, The International Maritime Organization is the major driver here. They've set ambitious decarbonization targets, and ammonia is seen as a key component in that push, again, because it can be combusted without associated carbon emissions. Major shipping technology providers have demonstrated ammonia burning engines, and we should see ammonia-ready ships roll off of production lines this year. So these new markets for clean ammonia are helping the clean hydrogen projects and the global clean hydrogen market to develop. If we just think about or look at what we would consider to be advanced clean hydrogen projects, so projects that are either under construction or undergoing front-end engineering and design, over half of the capacity in these advanced projects globally is seriously considering or targeting converting that hydrogen into ammonia to access these new end-use sectors. So therefore, supported by policy and technology development, we see ammonia as a key growth vector for clean hydrogen markets globally. And we expect this trend to accelerate as we look out not just to the end of this decade, but also into the next decade. Thank you for watching today.